Have you ever really stopped to think about the metal in your phone or your car or even just the fork you eat with? It's been on this incredible hidden chemical journey, a journey that takes a totally ordinary looking rock and turns it into the materials that build our entire world. That whole process is called metallurgy, and we're going to dive right in. So here's the big question, right? How in the world do you get from this raw kind of reddish rock called bauxite, to something you have in your kitchen right now? A simple sheet of aluminum foil. That's the transformation we're going to unpack. And believe me, it involves a whole lot of crushing, washing, intense heat, and even some serious electricity. Okay, so the first thing you've got to understand is that the metals we want, like aluminum, iron, copper, they aren't just lying around for the taking. Nope, they're chemically locked up inside rocks. So our first job is to figure out exactly which rocks are the right ones to go after. And that brings up a really key distinction. You've got minerals and you've got ores. A mineral is basically any rock that has some metal in it. But an ore is the jackpot. That's a mineral that has so much metal packed inside that it's actually profitable to go through the whole long process of getting it out. I mean, if you can't make money off it, it's just a rock. All right, so once we've found our profitable ore, we hit our first big hurdle. The ore is never pure. It's always mixed in with a ton of worthless rock and dirt. So this first part of the journey is really just one giant separation project. And all this unwanted gunk, it actually has a name: gang. You can kind of think of gang as the villain of this first act. It's all the sand, the dirt, and the other useless bits that are mixed in with our valuable ore, and our number one job is to get rid of it. So, to beat the gang, metallurgists have this whole bag of tricks called ore concentration. First, they just crush the heck out of the ore, grinding it into a fine powder. Then, depending on what kind of ore it is, they might wash it with water or use this really cool process with oil and bubbles called froth flotation, or they might even just use giant magnets. The goal is always the same though: get more of the good stuff and less of the bad stuff. Let's just zoom in on the magnetic method for a second, because it's just so simple and brilliant. You take the crushed powder and drop it onto a conveyor belt. But here's the trick. One of the rollers is a powerful magnet. So the non-magnetic gang, the useless stuff, just falls off into a pile like you'd expect, but the magnetic ore particles, they literally cling to the belt for just a split second longer, long enough to fall into a completely different pile. So simple, but so effective. Now that we've got a much more concentrated ore, we're ready for the really dramatic part of the journey, the trial by fire. This is where we bring in the intense heat and some serious chemistry to finally break that metal out of its mineral prison. There are two main ways this starts, and it all comes down to one thing: oxygen. Roasting is when you heat the ore with a ton of air blasting through. That's great for sulfide ores. But then there's calcination. That's when you heat it up with no air. That's what you do for carbonate ores. Two different approaches to achieve the same goal. Okay, after that first heating step, we get to the main event: smelting. This is where things get seriously hot. We take the metal oxide and heat it in a furnace with what's called a reducing agent, usually just carbon. The carbon basically rips the oxygen atoms away from the metal. At the same time, we add something called a flux, which helps any leftover gang melt and float to the top as this glassy waste called slag. But get this, sometimes chemistry does something that's just mind-blowing. In some cases, like with certain copper ores, you don't even need to add a reducing agent. You just heat the ore and the different parts of it start reacting with each other. The ore itself does the reducing. It's called autoreduction, and what you're left with is pure molten copper. The metal literally refines itself. How cool is that? So the metal that comes out of that smelter, it's often called crude metal, is good, but it's not great. It's still got little bits of impurities in it. And for a lot of the high-tech stuff we use today, we need extreme purity. So our journey has one last stop: a final polish. So let's circle all the way back to our aluminum foil. To get that super pure product, we use something called electrolytic refining. You take the concentrated aluminum oxide, dissolve it in a molten bath, and then you pass a massive electric current through it. That powerful current forces the aluminum to become pure metal, which then sinks to the bottom where it can be collected. It takes an absolutely incredible amount of energy, but it gets you that 99.5% pure aluminum we use every day.
So now that we see the modern, high-energy process, it's even more amazing to look back and see how skilled ancient metallurgists were. So for this, we're going to take a trip to Delhi, India, to look at a very, very special pillar of iron that has had scientists scratching their heads for centuries. First thing you need to know is its age. This iron pillar has been standing in the Qutb complex for about 1,600 years. Just let that number sink in for a second. 1,600 years.
Okay, fine, it's old. A lot of things are old. But why is this a metallurgical marvel? What is the big deal about this one particular piece of ancient iron that makes it so famous? And here it is. This is the kicker. Think about any old iron you've ever seen. A gate, a tool, anything. It rusts. But this pillar, after 16 centuries of monsoons, heat, and pollution, has barely rusted. At all. By all rights, it should have crumbled into a pile of dust hundreds of years ago, but it hasn't. So what is the secret? Well, after a ton of modern analysis, scientists figured it out. It's a unique, incredibly thin protective layer that formed on the surface over time. This special compound, a type of iron oxyhydroxide called misoite, formed because the ancient iron had a high phosphorus content. Over the centuries, this layer became a natural shield, completely stopping rust in its tracks. It's like it grew its own perfect rust-proof armor. Just an incredible testament to the skill of those ancient ironworkers. So you see, the journey from rock to product isn't just about mining and fire. It's a story of physics, of brilliant chemistry, and of centuries of human ingenuity. It really makes you wonder, doesn't it? What other incredible hidden journeys are locked away inside the ordinary things you use every single day?